Solving equations, linear equations, and inequalities. Alright, let's look at solving linear equations first, and then I'll just show you how to do the linear inequalities. And I said that the basic idea is I want to get all of the x values on one side of the equal sign and all of the number values on the other side of the equal sign. And if they are not separate terms, I will just go and separate them so that I can get all of the x's on this side and all of the numbers on the other side. So for instance, let me show you how it's done. If I have, this is quite simple, x minus 5 is equal to 6. What I want to do is I want to get the x values on one side. This one is on the left hand side, and I just take the number values to the other side. So I have 6 plus 5. You can write the separate steps, 6 plus 5, and then in the next line x is 11. But work towards doing this step in your head. 6 plus 5 is 11, and just writing 11. So let's look at a little bit more, one step more difficult. Say for instance I have this 2x minus 3 is equal to 11. I want to get the x values on one side of the equal sign and the number values on the other side of the equal sign. So I gather all of the numbers on this side, and you know that if I take a number over, it changes the sign. And then I have 2x is equal to 14, which from here on, after I've done this x's numbers, I just simplify by doing x is equal to 7. I divided both sides by 2. So I'm going to do a few like this, but I'm going to keep on making it more difficult and more difficult. The idea is to build on the knowledge from basic to as difficult as you can get. So say for instance I have 2x plus 3 minus 4. Now I have x's on both sides, x minus 1, 3 times x minus 1, and I don't have my x and my numbers separated already. Can you see that there is now an x and a number in the bracket, and I don't want x's and numbers together. I want them separated because I want to separate the x's on this side and the numbers on that side. So to split this number and the x value, I'm going to multiply the 2 in, I'm going to multiply the 3 in. So I have 2x plus 6, 2 times 3, and then minus 4 is equal to, and this 3 I multiply in, 3x minus 3. And now I gather all of the x's on this side. So I have the 2x and this 3x I take over, so that all of the x's are on this side. And on the other side I have negative 3. I'm going to take, you can either take over the 6, make it negative, take over this 4, make it positive, or you can see that 6 minus 4 is 2 and go and minus 2 on the other side. You can see that minus 6 plus 4 is also going to give the same effect as minus 2 on this side. So whichever way you prefer. And then 2x minus 3x is minus x, and this is then minus 3 minus 6 is minus 9 plus 4 is minus 5, or you would have said minus 3 minus 2, which is minus 5. Either way is fine. So if minus x is minus 5, that means that x should be 5. Mathematically I just multiply throughout with a negative 1 to get rid of this negative, or divide by negative 1 to get rid of this negative. I simultaneously quickly want to show you how this would work as an inequality. Say for instance I didn't have an equal sign there, but I had let's make it a smaller than sign there. So say for instance I had 2 times x plus 3 minus 4 smaller than 3x minus 1. Just to show you that the concept works the same in inequalities and equations, the concept works the same. The only thing that really changes is I work instead of an equal sign with a smaller than sign, and if I multiply or divide by a negative, then I'm going to swap the sign around, but the rest of it stays the same. So first of all, I'm going to multiply out exactly as I did in that step to get 2x plus 6 minus 4 is smaller than 3x minus 3. And then the next step, same as there, I'm going to gather the x's and gather the numbers. I just want to move the board so that you can see properly. So I gather all of the x's on this side and I gather all of the numbers. There's a minus 3, take over the minus 4, plus 4, take over the 6, becomes minus 6. Oh, this is a problem that you can't see there. Let me just see if I can maybe fit it in somehow. I have minus 3 plus 4 minus 6. Yes, now you can see that all. And then this I simplify to minus x, same as I did there. The only thing is I now have a smaller than instead of an equal sign, and this becomes minus 5, same as there. The only thing that really changes now is now I'm going to multiply with a negative 1 throughout to get rid of this negative. And whenever I multiply with a negative 1, I'm going to take this smaller than and make it a bigger than. Right, so can you see, because I multiply with a negative number, oh, this is a problem, because I multiply with a negative number, I'm going to swap this sign around, and then this becomes x is bigger than 5. Now why this would happen, let me quickly just explain this to you. You know, a number line starts there in the middle 0, and on this side I have 1, 2, 3, 4, 5, 6, etc. And minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, etc. Can you see, if you look at the number line, you know on a number line this side is bigger than this side. As I go to this side on the number line, look at the positive numbers. As I move on the number line to this side, I move bigger, and as I move to this side, I move smaller. Right, get that direction in your head, smaller, bigger, smaller. Get that in your head first. Now look at the positive numbers. As I go 1, 2, 3, 4, 5, it gets bigger. But the negative numbers, as I go negative 1, negative 2, negative 3, as the numbers actually in my head gets bigger, can you see the negative numbers become smaller? And if I have numbers, can you see bigger than 5? If I have numbers bigger than 5, they're going to lie to this side, right? To that side, which because this side is bigger than 5. So from 5 on, all the bigger numbers would be that, all the smaller numbers would be to this side. Now if I look at negative 5, if I mirror this so that I want numbers to that side of 5, meaning 6, 7, 8, 9, 10. If I look at the negatives, if I want negative 6, negative 7, negative 8, I'm actually going to go smaller. Can you see? This side is smaller. So if I work with the numbers and I mirror them, instead of pluses, I work with negatives, it's going to mirror, but bigger is going to become smaller and smaller is going to become bigger, and that is why smaller than change to bigger than when I multiply, when I change from negative to positive, smaller than becomes bigger than. Okay, so I hope that makes a little bit of sense to you. I'm gonna do another problem and then I'll also do the inequality for you so that you can again see that the inequality and a equation works pretty much the same. So let's look at x over 3 minus 4 is equal to x over 9. Right, now this is a question with fractions, and whenever you work with fractions, what you want to do is you look at the denominators of all of the fractions, and you compare the denominators, and you find the lowest common multiple of the denominators and multiply throughout of the equation, throughout from the beginning to end on this side and this side with the lowest common multiple of the denominators. Now, you remember the lowest common multiple means if I look at the times tables of 3 and the times tables of 9, the smallest number that they have in common. So if I think of 3, 3, 6, 9, 12, and I think of 9, 9, 18, the smallest number that they share in their set of multiples is 9. So I'm going to multiply with 9. By the way, for x's and y's and z's, for x values, for variable values, the lowest common multiple will always be the highest exponent. So if I have, for instance, x squared and x to the power of 5, the lowest common multiple will be the highest exponent, which is x to the power of 5. So I'm going to multiply throughout with 9. Now x over 3 times 9 is 3x, and 4 times 9 is 36, and x over 9 times 9 is just x. You can either multiply it, it's better if you can multiply it straight through with 9 like this. If you still struggle, something you can do is to just go and write this equation a little bit more expanded, and then to multiply throughout with 9, I can multiply with 9 over 1, multiply with 9 over 1, and multiply with 9 over 1. I'm going to write that with a pencil like that. Now can you see that 3 goes into 3 once and 3 goes into 9 3 times, so 3 times x gives me this. And 4 times 9, because this is 4 over 1 times 9 over 1, 4 times 9 is 36, and 1 times 1 is over 1, which I don't need to write. And the 2 9s cancel out, so I just have x left. So you're welcome to fill in some extra steps like this. Just expand it and multiply, write at every single term the thing you're multiplying with throughout, and simplify each one like a little problem on its own. But it's better, this can be very time consuming, so towards the end of matric it's better to be able to do it like this. So work on this so that you can do it like that. Alright, and now I'm going to group all of the x's on one side and all of the numbers on the other side. And 3x minus x is 2x, so x is 2x is 36. That means that x must then be 18. Alright, I'm just quickly going to do the inequality for you also, so that you can see what would happen with the inequality of this. Say for instance I have x over 3 minus 4 is bigger or equal to x over 9. What would happen is I'm still going to multiply throughout with 9 like I did there. So if I multiply this by 9, I have 9 divided by 3 is 3, and then there's a x, so 3x. 9 times 4 is 36, bigger or equal to, and x over 9 times 9 is just x. And then I'm going to gather all of the x's, so I have 3x minus x is bigger or equal to, to 36. So I have all of my x terms on this side, my 36 on that side, and this is then 2x is bigger or equal to 18. That means x is bigger or equal to 18 divided by 2, which is 9. And since I now divided by a positive number here, can you see I don't change the sign around, I leave it just as it is. So this works exactly like this. I just changed the equal to bigger or equal to. The only thing that can be different is if I have a negative x, then I multiply or divide by a negative number, then I must just turn the sign around. If it's bigger than, I make it smaller than. If it's smaller than, I make it bigger than. So let's look at one last example of a fraction type solving equation, which is also a linear equation. Say for instance I have 2x minus 1 over 5 is equal to, and I don't know if you can see that that's a 5. Ugh, toch. I don't know if you can see that that's a 5, so I'm just going to rewrite it so that it's a pretty 5. Now ain't that pretty. Right, and then I have 3x minus 1 over 10. Okay, now what I want to do is gather the x's and gather the numbers, but now there's x's and numbers on top of a fraction, and I don't like working with fractions. Whenever I'm faced with fractions, not that I don't like working with fractions specifically, but in solving equations, there's no specific method to do anything with a fraction. You get rid of the fraction by multiplying with the the lowest common multiple of the denominators. So what I'm going to do is I'm going to multiply by 10 over 1 if you need to, 10 over 1 if you need to, but you really don't need to write that. You can just multiply the 10 on top both sides. Multiply by 10 on both sides, and can you see that 10 over 5 becomes 2, and the 10s there cancel out completely. So I'm left with 2 times 2x minus 1, and please don't multiply the 2 only with the 2x. Put brackets around the 2x minus 1 so that you multiply the 2 with the complete numerator, and there I have 3x minus 1. Now I'm just going to multiply the 2, so I have 4x minus 2, not 4x minus 1, if I multiply the 2 only with the first one. And this now gives me this. I gather all of the x's, I gather all of the numbers, and I have 4x minus 3x, which is a perfect x, so I don't even need to worry further about that, and that is 1. So lovely, x is 1, and I am done. And you can, if you want to go and test, if I fill in 1 there, I get 2 times 1, which is 2, minus 1 is 1 over 5. And if I fill 1 in there, I have 3 times 1, which is 3, minus 1 is 2 over 10. And I know 2 over 10 and 1 over 5 are equal. So great.